Hello everybody, welcome to this vlog. My name is Satya. Today as part of this vlog, I'll discuss about how the video streaming works in our homes. Either it can be from the set-top box that we use or from the smart TV apps like Netflix, YouTube, Amazon Prime, etc. Right? So in this class, I'll primarily use an example of YouTube video streaming. So to start with, we need to understand that YouTube is a data center, right? So when I call data center it is a storage of videos across the world, right? So you might have heard that, for example, in India they are coming up with YouTube and Google. They are coming up with a data center, huge data center in Vishakhapatnam, right, in India, south of India. So what this data center will how this data center will make an impact technologically, and how it will create jobs for us, it's very important to keep in mind. So this video will help how YouTube as an application, a streaming video server, will use this data center to stream the videos to the end users, right? So let's see what happens when a set-top box or a smart TV box boots. The first step is, when we start the smart TV box, for example, which has YouTube as an application, it will first query for www.youtube.com URL. That is, it will send a DNS query saying who has www.youtube.com. Because it's an URL, it needs to be translated into an IP address. So a DNS server maintained by Google, right, will respond, or the Google server or the DNS server maintained by your home router will respond to this DNS query saying the IP address for www.youtube.com is xxxx, right? Or let's say take an example of 52.52.52.52 example IP address for YouTube YouTube URL. Then that URL is an HTTPS portal get access. Once you get the IP address, you will say HTTPS get. HTTPS stands for Hypertext Transport Protocol in secure mode. It will say get the uh, application buttons or tabs that is there in the YouTube. It will give all the different information about the HTML page or whatever page the YouTube server has as a starting server URL, a server page, right? That is the third step. Once you get it, right? So then movie catalog download. So movie catalog download will be downloaded. Either it can be in the YouTube, it will be different videos. User clicks on a movie, right? So what happens when you click each one of them, I'll explain later. But if user clicks on a movie or a video, it will start playing, right? So video chunk request begins. Seventh step, continuous VXLAN transport. Now in the last vlog, or in one of the vlogs, I explained about the VXLAN being a overlay. Now VXLAN is used in data center as an overlay to service different requests from the end user, right? Then ninth step is home VTEP decapsulates the home VTEP, in the sense, for example, each users will be given one VTEP, that is virtual VXLAN tunnel endpoint, right? They'll be given one tunnel endpoint. They decapsulate the packet and then transmit it according to the VRF or a layer 2 traffic inside the data center, right? Then 10th step with STP plays the video. Now I will explain again. Smart TV, when it boots up, it will send a DNS lookup for YouTube, right? Because when smart TV boots up, it can be YouTube. Once you open a panel where YouTube, Netflix, Amazon Prime are there, it will send a DNS query for all these applications, right? Now you click on YouTube, then the IP address translated by the DNS will be used by the smart TV box to get the HTTPS portal access. Then the movie catalog or the video catalog downloads, user clicks on the movie. As soon as it clicks on the movie, again another IP packet will go uh, to the server to play the video, right? Then how the data center manages this video, because you're requesting for one video and that video might be in a one VM, and you're clicking your whatever page that you got is on another VM in the sense virtual machine, right? As I told in the last vlog, or in the VXLAN vlog, that VMs form the center of data center, right? So on one VM, the login page of YouTube will appear, the server URL will come with the movie catalog and all. Other VM will have the actual video. So now how it will traverse the data center is managed by the overlay VXLAN network that I will describe in detail in the future of this video, right? So then the video actually plays on the smart TV box. So that is the first thing that we need to keep in mind, right? So the next one is the function actually. What actually the function means. So when you're accessing or translating the URL, server URL, YouTube server URL into an IP address, it is using DNS, right? So in the same way, overlay transport is VXLAN as the protocol. Underlay is IP MPLS. IP stands for Internet Protocol and MPLS stands for multipath label switching. Right? Video browsing is uh, when you browse through the YouTube, the video browser is using HTTPS GET. Streaming is HTTP live stream or dash. Encryption is TLS, transport layer security. The HTTPS packets will be secured at the transport layer using TLS. Video transport is TCP 443. TLS port is destination port is 443. And the service discovery, how YouTube URL is translated into the IP address, is using domain name server. Okay, so the next point that you need to keep in mind is what ISP VXLAN sees. YouTube will have the data center. You are using the ISP infrastructure to reach to the data center, right? So now the data center is seeing VXLAN only the outer routable IPs, that is virtual tunnel endpoint IPs, UDP protocol 4788, 4789, and the encrypted HTTPS traffic. Okay, so then next is how exactly will be the packet that will be seen by the home VTEP, that is home virtual tunnel endpoint. The outer IP, for example, if your source IP is 192.168.1.20, destination will be 192.168.1.10, which is on the same layer 2 network. UDP destination port is 4789. VXLAN VNI is virtual network identifier, that is 10100, right? So and it is number of combination that can be possible is 2 to the power of 24, which is like almost greater than 16 million networks can be formed. And the inner IP is the layer 2 IP. This is the outer one which is routable, and the inner IP is the layer 2 IP. So the finally how the packet will look on the end device when you capture Wireshark, using Wireshark on your smart TV box by connecting Wireshark capture, you will see that source MAC is set-top box MAC or the smart TV box MAC. Destination MAC is a destination gateway MAC. IP is source 10.10.10.50, destination is 10.10.10.200, and source port is 5200. It can be any port in the range from 1000 to 65,535, and the destination port is 443, which is TLS, transport layer security, and TLS payload is encrypted video segment request. So this is in a nutshell how the networking happens when you do a YouTube streaming. Now I want to explain to you step by step what happens when you start a YouTube application on your smart TV box. When you are at home, the real users will use home connection, home gateway, which is called as which is basically provided by in India. If you are viewing this video from India, or if you are located in India, then your home gateway will be provided by either Geo network, Geo company, or Airtel company, or a BSNL or VSNL. So in the different companies are there which provide the home, or Act FiberNet is also quite popular in India now. So they will provide the home gateway, right? So either you will connect through Wi-Fi to the smart TV box, or you connect directly through the LAN cable, Ethernet cable, to the home gateway. Once you send and once you start this smart TV box, you would have already, smart TV box will first request for an IP address saying what should be my IP address, right? That is dynamic host configuration protocol. DHCP client on smart TV box will ask for an IP address, and you will get 10.10.10.50. 10.10.10.50 will be your IP address, right? That will be provided by the DHCP. Then default route is also provided, which is the home router, which is the next hop in your packet transfer, right? That will be usually in the same segment as 10.10.10.50. So let's suppose it is 10.10.10.254. I have not put it here, but let's suppose the gateway is the home gateway IP address is 10.10.10.254. Now, once you start it, you got an IP address, you go to a panel where YouTube is available. Once you open the panel of the applications, YouTube, Amazon Prime, Netflix, etc., 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 it will request for the DNS resolution of all these applications. YouTube will get an IP address, which is, for example, 52.52.52.52, right? And the Google DNS server is famous Google DNS server, which is 8.8.8.8. So smart TV box will send from 10.10.10.50 to 8.8.8.8, right? So once it sends, the home gateway will have a NAT application, because yours is a private address, which is 10.10.10.50. It will translate it into a public address, and it will give it to, and it will use that as a source address, and it will contact 8.8.8 for DNS resolution. Once you get 52.52.52.52.52.52 from the DNS server, you will try to contact the YouTube application server, right? Now you have your own IP, which is 10.10.10.50, and you have to go to 52.52.52.52 for the YouTube server, right? So till then it will be normal ISP routed packet. Once you send 10.10.10.50 IP address, and you not send, use the 10.10.10.50 to send a packet to 52.52.52.52, it will, through the ISP network, using normal routing protocols like BGP, or OSPF, or ISIS, it will reach the YouTube server which has the videos being displayed there. A thumbnail will be displayed. Now, once it is reached there, you click on a one particular video, right? So that is the HTTPS gate. That is what we described in step 3 in the previous PowerPoint slides. So step 3 is HTTPS gate of the YouTube videos application panel, where it has all the videos. It gets populated. Now you click on a particular video. Now once you click on a particular video, that video, right, needs to be searched in the video data center repository. It might be another VM, right? So we were in one VM with a public IP address as 52.52.52.52, but the video streaming should happen on a separate from a separate server, right? For example, you requested for Avengers movie to be streamed. So Avengers actual video stream videos file is present in some VM. So how will we find via a VM of that? It will be tagged to that particular uh, applet in the once you click that, that information will be available there, which IP address it needs to contact. Now from that VM, which is the OM VTEP, right? So the OM VTEP is OM virtual tunnel endpoint server. That is your home for contacting the actual video server. Now from here starts the VXLAN. Now data center, what we are imagining in Visakhapatnam is a huge data center. It might be servicing a lot of Google applications. One of the applications that I told here is YouTube. Now YouTube, using the microservices architecture or Kubernetes, which is running the pods actual, see, if you want to understand the Microsoft architecture or pods in a cloud computing or in data center, that's a separate topic itself. Now you need to assume that we need to get the packet from the video, actual video file from a particular VM to the OM VTEP. So how will we do that? So what we do is we send for a request packet. Maybe a data center has a one internal packet type to get the video transfer working from a particular VM. So now this is a huge data center with a lot of overlay architecture and underlay architecture. As I explained in the VXLAN video, overlay is for VMs, actual data center. Underlay is the network that provides these services, how the packet traverses from one VM to other VM. This is layer 2 networking, right? So if OM VTEP VNI is 10010, then 10010, that video might be in a different VNI or in the same VNI. If luckily, if it is in the same VNI, then it is layer 2 streaming. If it is in a separate VNI, then it is layer 3, right? That is called as IRB. That is integrated routing and bridging, right? So for that, let's suppose it's a layer 2 VM, right? It's in the same VNI. Then what it will do, it will send its own message saying, send me the video streaming packet, right? From how it will do is it will send a R packet to find out what is the IP address translated to MAC address for the next VM where the video file is there. You'll send a R packet as I explained in the VXLAN topic actually. It will send an ARP broadcast message. If the home VTEP already has a MAC address equivalent for that IP address destination of the destination VM, then excuse me, it will not send the R packet to the destination VM over the L2 network. If the IP address is not mapped to MAC address in the home VTAP, then it will bridge the ARP packet to L2 VNI to be responded by the actual VM itself. So here the VXLAN encapsulation happens. The home VTAP packet, when it ARP packet, when it goes out of home VTAP, it will encapsulate the packet in VXLAN and it will send it to the destination VM. There the VXLAN is again decapsulated and given to the actual video file. That video file says that you have to stream from this IP address, right? So that IP address, corresponding MAC address, will be sent to the home VTAP. Home VTAP will then translate that IP address to routed over the internet, and it will give it to the home gateway, not home VTAP, home gateway. Their home gateway will convert from that network address translation from public IP address to private IP address, and it will give it to the smart TV box to play the video. So this packet flow, unicast packet flow from the destination VM in the data center to the home VTAP. Home VTAP will give it to the ISP network. ISP network will give it to the home gateway. Home gateway will give it to the smart TV box. This is how the flow looks like. Now you may ask me that why we need to have this ISP network. Can we just override this ISP network and directly connect to the data center of Google for YouTube videos? Then there will be MAC explosion, because layer 2 network, all the communication happens on the MAC address. So if the ARP is sent for each of these IP addresses, all the IP addresses that are found in the data center, it will be millions or billions of IP addresses that will be their private IP address. For each IP address, if you want to translate and create a MAC table in the, then there will be MAC explosion. ARP table will be seriously having lakhs or millions of MAC address entries corresponding to each IP address. So that is not feasible, that is not scalable solution. So the first hop, that is from home gateway to the Google data center, it will be ISP network. Inside the ISP network, how the video is played, how the video file is being searched and given as streaming to the ISP network is done using VXLAN overlay, right? So now the most important point is, what are the different job opportunities in this particular technology? As I explained, let's go to the first slide that I showed you. STB boots. Now STB, smart TV box, it's a front end UI, right, which is stored locally or in the in the smart TV box. That particular screen that comes with YouTube, Netflix, Amazon Prime, you have to write a front end UI for it, where you put in YouTube, all these things, right? So now that is a front end job opportunity. If you are interested in developing a front end UI, that is where you need to focus on developing the user friendly screens for smart TV box, where you display different applets for YouTube application, Netflix application, and Amazon Prime application, etc., etc., etc. Then comes the DNS lookup, NAT translation, ISP NAT translation. That is a home router. Home router suppliers are might be from Cisco, Technicolor, Equinox, or for example TP-Link, D-Link. These are the different etc., etc. companies provide the home gateways, right? So there you put the logic of developing embedded software which has different protocols like DNS lookup, NAT gateway translation, firewalling, etc., etc. applications or protocols will be put in there. services. That is home gateway. So if you are an embedded software engineer, you can develop those application either on or you can develop your own Raspberry Pi. You buy a Raspberry Pi and start developing these applications uh, at for your convenience, right? Then HTTPS protocol access, portal access. So that is UI. So whatever technologies that are involved in making web UI is a job opportunity for web UI developers. Then backend for that web UI, right? How these uh, applications should look once you click on YouTube, what should be displayed, how it should be displayed, what is the styling, what is the XML content or CSS content. So that is another uh, job opportunity. That is third and fourth. Movie catalog download, the video catalog download, user clicks the movie. These are all the applications for front end UI. How the uh, home gateway will embed engineers will come. Then comes the main important part. You have discussed about smart TV, which is our own at our homes, right? It's a user appliance. Home gateway is a gateway to the ISP network, right? But in ISP, your packet should be routed, right? You are not the only person in this world accessing YouTube. There might be numerous. So how this packet is routed in the internet, that is provided by companies like Cisco, Equinox, Juniper, then Nokia. There are different companies which provide this backend or edge routers, which route these packets to the actual data center where the video is stored. Now, inside the data center, there will be a lot of VMs. These VMs can be either VNFs, virtual network function, or it can be CNFs, right? Um CNFs and VNFs I've explained in a separate video. You can have a look up what is the difference between VNF and CNF. So these VMs, virtual machines, needs to be handled because data center will have billions of IP addresses, and how to get one video file out of those billions of files. This transaction happens using microservices architecture, right? Kubernetes and microservices architecture. That is another job opportunity where these are all niche skill sets. So how to maintain the data center is a different uh, field itself, right? Then routing inside the data center is VXLAN overlay, right? So that itself is a separate niche skill. So finally, the streaming server, how it happens. Then, for example, using the streaming, when the streaming is happening, YouTube, there might be advertisements, right? So how the advertisement happens, I'm also not sure how the advertisement happens. I think it is deep packet inspection, where they put in the ads automatically as part of the packet streaming that happens for video, right? So friends, this is what in a nutshell happens when YouTube video is clicked on your TV, right? So there are different networking protocols, there are different UI protocols, there are different backend protocol, backend applications or backend database is used. Data center, how VXLAN overlays play their part, everything is described, right? So if you want to analyze, because my background is networking background, so if you are more interested in understanding VXLAN overlays, how the ISP routing happens, you can already visit a lot of videos that I have put in for VXLAN overlay, then layer 3 underlay network for VXLANs, and I have also described about how the ISP network looks like in one of the videos, and also home gateways I have described. What I have not got experience is front end UI development and back end UI development. So that I will try to collaborate with somebody with that experience and try to put those videos here so that it can be a complete set of education material that will be available in my video channel. Okay, Thank you for your time. See you in the next vlog.